Satellite is in a circular orbit around a planet outlined by the gravitational forces that speed the satellite up. This is my clue to you, okay? You could Google this or whatever, right? Okay, but look at the direction. Look at the direction of the velocity and the force acting on something, right? If it's going in a circle, the velocity is going to be tangential, and then the force is going to be exactly toward the center of this circle, okay? Well, there's something about that angle that's important, okay? Remember that work is force Fs cos theta, right? And that angle would be 90 degrees, right? All right. Show that for all objects orbiting the planet, RV squared equals GM, where R is the radius of orbit. Okay. So to do this, you're going to use the orbital condition, right, which is the mass of the satellite v squared over r. And this is ma, right? This is m times the centripetal acceleration, because the centripetal acceleration is v squared over r, right? That equals just the gravitational force. So g, mass of the planet, mass of the satellite, over r squared, okay? Let's cancel the satellite mass, do some math. You ought to be able to show that, okay? Now, spoiler alert here, okay? The question on the test is going to involve the other orbital condition, right, where the centripetal acceleration is 4 pi squared r over t squared, right? So you're going to go mass of the satellite, 4 pi squared r over t squared is g mass of the planet, mass of the satellite over r squared, okay? And there's a constant that they're asking you to solve for, okay? You are going to cancel the satellite mass. And I'm not going to say anymore. Okay, and then calculate the velocity of satellite B. You're just going to use this expression, right? So you're going to go the radius of satellite A times the velocity A squared is going to equal the radius of B's orbit, which you have, right? You've got everything so far, times the velocity B squared, and this is the only thing you're solving for. So just use that expression, right? And then calculate the mass of the planet. That's pretty easy too, right? You're just going to use RA, which you have, right, times VA squared. That's going to equal G, which is 6.67 times 10 to the minus 11th times the mass of the planet, right? So just go this times this divided by that. Okay. Now, on the test, let's just talk a little bit about the difference, right? Orbits in a circular orbit, right? Outline the origin of the force that acts on the moon. So take a look at, there's a couple questions that are not on the mock test. And the mock test is a little bit different, but I think you can handle this. This is orbit stuff, right? That we did last year. So review that. Review the orbit stuff, okay?